Hello, ladies and gentlemen. We're going to be talking about equilateral and isosceles triangles and stuff that's more in depth about them, more properties about them, and more theorems about them. So today you're going to need your notes, your orange foldable that you got from me, and your calculator. So in your little orange yellow foldable, we're first going to be talking about, you can see on that first tab, vocabulary. Then we're going to be talking about base angle theorems and their converses. And then we're going to be talking about corollaries to the base angle theorems, or some people say extensions too. Okay, so if you open up your first flap on the top part of the vocabulary page, you see these two triangles, the isosceles and equilateral triangle. This is just review for us. Remember that isosceles triangles are a triangle with two congruent sides, and an equilateral triangle has three congruent sides. And we also know that every single equilateral triangle is also equiangular, so all the angles in an equilateral triangle are congruent as well. So if you want to add those markings in, that would be awesome. Okay, so in the same flap, under the vocab flap, we have this new image, and it's also an isosceles triangle, which we've talked about before, but now we're going to be adding more definitions to parts of the isosceles triangle. So we already know that there are two legs on the isosceles triangle, which are the two congruent sides. We may have never labeled them legs, but that's what they're called. Then the third side, the non-congruent side, is called the base. It will always be called the base. And so after that, we have two angles that are called the base angles. These angles are the two angles connected to either side of the ends of the base on that segment, on that part of the triangle. And if you notice in our image here, these base angles are always congruent. They will always and forever be congruent. So make note of that. And then we also have up on top here the vertex angle. And the vertex angle is just the angle that's not connected to the base. So make sure you get all those little notes added into your notebook. So if we open up to our second flap labeled base angles and its converse, we're first going to read our base angle theorem. And that states that if two sides of a triangle are congruent, then the angles opposite of them are also congruent. So if we look at our number one image here, they're saying that we have two sides of a triangle congruent. And when they say that the angles opposite of them, they're talking about this angle and this angle. So they're saying this angle is congruent to this angle. Well, if we look at our image of the isosceles triangle, they're just referencing base angles. They're saying base angles are always going to be congruent. That's all. So with that, we can set up our equations and solve for x and y like our directions tell us to. So we have 7x plus 2 equal to 8x minus 7. If we subtract 7x from both sides and add 7 to both sides, we get 9 is equal to x. That's pretty simple, but we still have to find our value for y. So if we plug 9 back in to our angles here, we have 7 times 9, which is 63, plus 2 is 65. So we know that both of our angles measure 65 degrees. So we also know from our interior angles sum theorem that the measure of all the sum of the interior angles in a triangle is 180 degrees. So if we have 180 equal to 2y plus 65 plus 65, we can find y. And that reduces down to 180 is equal to 2y plus 130. Subtract 130 from both sides. 180 minus 130 is 50 equal to 2y. We get y is equal to 25. Looking at number 2 then, if my sides of the triangle are this side and this side, my base angles then are this angle, the 2x plus 4 angle, and the 4x minus 22 angle. So that's going to be our first equation that we can set up. 2x plus 4 is equal to 4x minus 22. So subtract 2x from both sides. And that simplifies down to 4 equal to 2x minus 22. Add 22 to both sides. 4 plus 22 is 26 equal to 2x. Divide by 2. Divide by 2. X is equal to 13. But now we still need to find my y value. So just like we did on the last one, we know that the sum of all the interior angles is 180 degrees. So 180 is equal to 4y plus, we need to figure out what the other two angles, what their degree measures are. So if we plug x back into here for this angle, we have 2 times 13, which is 26, plus 4 is 30 degrees. So then we also know, since they're congruent, the other angle is 30 degrees. So back to our equation, 180 is equal to 4y plus 30 plus 30. Well, 30 plus 30 is 60. Just filling in the rest of my equation. If we subtract 60 from both sides, we get, I'm going to start writing all my math over here because I'm running out of room. 120 is equal to 4y. Divide by 4 on both sides, and we get y is equal to 30. Okay, so now we're going to talk about the converse of the base angle theorem. And remember, converse just means in opposite order. Remember, the base angle theorem said if we have two sides congruent, then the opposite angles are congruent. So now we're just reversing that order. It says if two angles of a triangle are congruent, then the sides opposite of them are congruent. So if we look at number 3, the side opposite this angle is the 5x plus 7 side. The side opposite of this angle is the 42 centimeter side. So all we're saying here is that if we have two angles of a triangle congruent, the sides or the legs are congruent. So I'm just going to write up here, congruent legs. All right, so let's set up our equation so we can find the value of x. We have 42 is equal to 5x plus 7. All we have to do now is solve for x. 42 minus 7 is 35, equal to 5x. Divide both sides by 5. X is 7. Simple enough. So now what they're saying on number 4 is that this side is congruent to this side. So now let's set up that equation. 8x plus 19 is equal to 12x plus 3. Subtract 8x from both sides. Cancel out our 8x's. We get 19 is equal to 4x plus 3. Subtract 3 from both sides. 19 minus 3 is 16 is equal to 4x. Divide both by 4. We get x is equal to 4. So now we're going to look at the next flap, which is the corollary to the base angle theorem. So the base angle theorem is basically telling us that for every pair of congruent sides, there's also congruent angles. So using that knowledge, we can extend the base angle theorem to say that if a triangle is equilateral, then it is equal angular. So if a triangle has 3 equal sides, then it must have 3 equal angles. Just like we said in the isosceles triangle, the opposite angles will be congruent to each other. But because there's only 3 sides of a triangle, that means that all of the interior angles are going to be congruent to each other. So now let's try to find the value of x, y, and z. So we could set up an equation that says 4y plus 5x plus 25 plus 32z minus 4 is all equal to 180, but that wouldn't help us because we have multiple variables and there's no way we could solve that. But we do know that every single equal angular triangle, every triangle has 180 degrees, right? And every single equal angular triangle means that each angle has to be congruent, so each angle has to be 60 degrees because 180 divided by 3 is 60 degrees. So knowing that information, we can just set up each angle equal to 60. So let's start with 4y equal to 60. Divide both sides by 4, and you get y is equal to 15. Set up the next equation, 5x plus 25 equal to 60. Subtract 25 from both sides. Get 5x is equal to 35. Divide by 5, divide by 5. X is equal to 7. And then if we have 32z minus 4 equal to 60, add 4 to both sides, add 4 to both sides. 32z is equal to 64. If we divide both sides by 32, we get z is equal to 2. Okay, so last but not least, the corollary to the converse of the base angles theorem. Remember, converse means reverse or in the reverse order. So we just talked about how the corollary was if a triangle is equilateral, then it's equiangular. So now the converse of that is saying if a triangle is equiangular, then it is equilateral. So if we look at number 6, it's telling us to find the perimeter of the triangle. So we have 3 angles are all congruent, so we know that all the sides are congruent. So first we're probably going to have to solve for x. Plug x back in to find the side length of one side, multiply it by 3 in order to find the perimeter. So our first equation would be 9x minus 11 is equal to 6x plus 16, minus 6x from both sides. 9x minus 6x is 3x minus 11 is equal to 16. Add 11 to both sides. We get 3x is equal to 27. Divide by 3, x is equal to 9. But I'm not done. They asked me to find the perimeter of the triangle. So before I can find the perimeter, I have to plug x back in to here so that I can find the length of one side. 9 times 9 is 81, minus 11 is 70. So we know that the side length are all 70 centimeters on all 3 sides of the triangle. And so 70 times 3 then is 210 centimeters for the perimeter. I want to thank you all for taking good notes, and I will see you tomorrow.